Atom, smallest indivisible unit of a chemical substance. Atoms are very small pieces of matter. There are many different types of atoms, each with its own name, mass, and size. These different types of atoms are called chemical elements. The chemical elements are organized on the periodic table. Examples of elements are hydrogen and gold. Atoms are very small, but their exact size depends on the element. Atoms range from 0.1 to 0.5 nanometers in width. 1 nanometer is about 100,000 times smaller than the width of a human hair. This makes atoms impossible to see without special tools. Scientists discover how they work and interact with other atoms through experiments. Atoms can join together to make molecules. For example, 2 hydrogen atoms and 1 oxygen atom combine to make a water molecule. When atoms join together, it is called a chemical reaction. Atoms are made up of 3 kinds of smaller particles, called protons, neutrons, and electrons. The protons and neutrons are heavier and stay in the middle of the atom, which is called the nucleus. The nucleus is surrounded by a cloud of lightweight electrons. These are attracted to the protons in the nucleus by the electromagnetic force because they have opposite electric charges. The number of protons an atom has defines what chemical element it is. This number is sometimes called its atomic number. For example, hydrogen has 1 proton and sulfur has 16 protons. Because the mass of neutrons and protons is very similar and the mass of electrons is very small, we can call the amount of protons and neutrons in an atom its atomic mass. Atoms move faster when they are in their gas form because they are free to move than they do in liquid form and solid form. In solid materials, the atoms are tightly packed next to each other so they vibrate, but are not able to move. There's no room, as atoms in liquids do. History. The word atom comes from the Greek atomos, indivisible. The first historical mention of the word atom came from works by the Greek philosopher Democritus around 400 BC. Atomic theory stayed as a mostly philosophical subject, with not much actual scientific investigation or study until the development of chemistry in the 1650s. In 1777, French chemist Antoine Lavoisier defined the term element for the first time. He said that an element was any basic substance that could not be broken down into other substances by the methods of chemistry. Any substance that could be broken down was compound. In 1803, English philosopher John Dalton suggested that elements were tiny, solid balls made of atoms. Dalton believed that all atoms of the same element have the same mass. He said that compounds are formed when atoms of more than one element combine. According to Dalton, in a certain compound, the atoms of the compound's elements always combine the same way. In 1827, British scientist Robert Brown looked at pollen grains in water under his microscope. The pollen grains appeared to be jiggling. Brown used Dalton's atomic theory to describe patterns in the way they moved. This was called Brownian motion. In 1905, Albert Einstein used mathematics to prove that these seemingly random movements were caused by the reactions of atoms, and by doing this, he conclusively proved the existence of the atom. In 1869, Russian scientist Dmitry Mendeleev published the first version of the periodic table. The periodic table groups elements by their atomic number, how many protons they have. This is usually the same as the number of electrons. Elements in the same column or period usually have similar properties. For example, helium, neon, argon, krypton, and xenon are all in the same column and have very similar properties. All these elements are gases that have no color or no smell, Also, they are unable to combine with other atoms to form compounds. Together, they are known as the noble gases. The physicist J.J. Thomson was the first person to discover electrons. This happened while he was working with cathode rays in 1897. He realized they had a negative charge, unlike protons, positive, and neutrons, no charge. Thomson created the plum pudding model, which stated that an atom was like plum pudding. The dried fruit electrons were stuck in a mass of pudding protons. In 1909, a scientist named Ernest Rutherford used the Gerger-Marston experiment to prove that most of an atom is in a very small space called the atomic nucleus. Rutherford took a photo plate and covered it with gold foil, and then shot alpha particles made of 2 protons and 2 neutrons stuck together at it. Many of the particles went through the gold foil, which proved that atoms are mostly empty space. Electrons are so small they make up only 1% of an atom's mass. In 1913, Niels Bohr introduced the Bohr Model. This model showed that electrons travel around the nucleus in fixed circular orbits. This was more accurate than the Rutherford model. However, it was still not completely right. Improvements to the Bohr model have been made since it was first introduced. In 1925, chemist Frederick Soddy found that some elements in the periodic table had more than one kind of atom. For example, any atom with 2 protons should be a helium atom. Usually, a helium nucleus also contains 2 neutrons. However, some helium atoms have only 1 neutron. This means they are truly helium, because an element is defined by the number of protons, but they are not normal helium either. Soddy called an atom like this with a different number of neutrons an isotope. To get the name of the isotope, we look at how many protons and neutrons it has in its nucleus and add this to the name of the element. So a helium atom with 2 protons and 1 neutron is called helium-3, and a carbon atom with 6 protons and 6 neutrons is called carbon-12. However, when he developed his theory, Soddy could not be certain neutrons actually existed. He proved they were real. Physicist James Chadwick and a team of others created the mass spectrometer. The mass spectrometer actually measures the mass and weight of an individual atoms. By doing this, Chadwick proved that to account for all the weight of the atom, neutrons must exist. In 1937, German chemist Otto Hahn became the first person to create nuclear fission in a laboratory. He discovered this by chance when he was shooting neutrons at the uranium atom, hoping to create a new isotope. However, he noticed that instead of a new isotope, the uranium simply changed into a barium atom, a smaller atom than uranium. Apparently, Hahn had broken the uranium atom. This was the world's first recorded nuclear fission reaction. This discovery eventually led to the creation of the atomic bomb. Further into the 20th century, physicists went deeper into the mysteries of an atom. Using particle accelerators, they discovered that protons and neutrons were actually made of other particles called quarks. The most accurate model so far comes from the Schrödinger equation. Schrödinger realized that the electrons exist in a cloud around the nucleus called the electron cloud. In the electron cloud, it is impossible to know exactly where electrons are. The Schrödinger equation is used to find out where an electron is likely to be. This area is called the electron's orbital. Structure and parts. The complex atom is made up of 3 main particles: the proton, the neutron, and the electron. The isotope of hydrogen, hydrogen-1, has no neutrons, just the 1 proton and 1 electron. Protons have a positive electric charge and electrons have a negative charge. A positive hydrogen ion has no electrons, just the one proton. These two examples are the only known exceptions to the rule that all other atoms have at least one proton and one neutron and one electron each. Electrons are by far the smallest of the three atomic particles. Their mass and size is too small to be measured using current technology. They have a negative charge. Protons and neutrons are of similar size and weight to each other. Protons are positively charged and neutrons have no charge. Most atoms have a neutral charge. Because the number of protons, positive, and electrons, negative, are the same, the charges balance out to zero. However, in ions, different number of electrons, this is not always the case, and they can have a positive or a negative charge. Protons and neutrons are made out of quarks of two types, up quarks and down quarks. A proton is made of two up quarks and one down quark, and a neutron is made of two down quarks and one up quark. Nucleus. The nucleus is in the middle of an atom. It is made up of protons and neutrons. Usually in nature, two things with the same charge repel or shoot away from each other. So for a long time it was a mystery to scientists how the positively charged protons in the nucleus stayed together. They solved this by finding a particle called a gluon. Its name comes from the word glue, as gluons act like atomic glue, sticking their protons together using the strong nuclear force. It is this force which also holds the quarks together that make up the protons and neutrons. The number of neutrons in relation to protons defines whether the nucleus is stable or goes through radioactive decay. When there are too many neutrons or protons, the atom tries to make the numbers the same by getting rid of the extra particles. It does this by emitting radiation in the form of alpha, beta, or gamma decay. Nuclei can change through other means too. Nuclear fission is when the nucleus splits into two smaller nuclei, releasing a lot of stored energy. This release of energy is what makes nuclear fission useful for making bombs and electricity in the form of nuclear power. The other way nuclei can change is through nuclear fission, when two nuclei join together or fuse to make a heavier nucleus. This process requires extreme amounts of energy in order to overcome the electrostatic repulsion between the protons, as they have the same charge. Such high energies are most common in stars like our Sun, which fuses hydrogen for fuel. Electrons. Electrons orbit or travel around the nucleus. They are called the atom's electron cloud. They are attracted towards the nucleus because of the electromagnetic force. Electrons have a negative charge, and the nucleus always has a positive charge, so they attract each other. Around the nucleus, some electrons are further out than others in different layers. These are called electron shells. In most atoms, the first shell has 2 electrons, and all others have 8. Exceptions are rare, but they do happen and are difficult to predict. The further away the electron is from the nucleus, the weaker the pull of the nucleus on it. This is why bigger atoms with more electrons react more easily with other atoms. The electromagnetism of the nucleus is not strong enough to hold onto their electrons when atoms lose electrons to the strong attraction of smaller atoms. Radioactive decay. Some elements and many isotopes have what is called an unstable nucleus. This means the nucleus is either too big to hold itself together or has too many protons or neutrons. When this happens, the nucleus has to get rid of the excess mass or particles. It does this through radiation. An atom that does this can be called radioactive. Unstable atoms continue to be radioactive until they lose enough mass particles that they become stable. All atoms above atomic number 82 are radioactive. There are 3 main types of radioactive decay: alpha, beta, and gamma. Alpha decay is when the atom shoots out a particle having 2 protons and 2 neutrons. This is essentially a helium nucleus. The result is an element with atomic number 2 less than before. So for example, if a beryllium atom number 4, went through alpha decay, it would become helium, atomic number 2. Alpha decay happens when an atom is too big and needs to get rid of some mass. Beta decay is when a neutron turns into a proton or a proton turns into a neutron. In the first case, the atom shoots out an electron. In the second case, it is a positron, like an electron but with a positive charge. The end result is an element with 1 higher or 1 lower atomic number than before. Beta decay happens when an atom has either too many protons or too many neutrons. Gamma decay is when an atom shoots out a gamma ray or wave. It happens when there is a charge in the energy of the nucleus. This is usually after a nucleus has already gone through alpha or beta decay. There is no charge in the mass or atomic number of the atom, only in the stored energy inside the nucleus. Every radioactive element or isotope has what is named a half-life. This is how long it takes half of a sample of atoms of that type to decay until they become a different stable isotope or element. Large atoms or isotopes with a big difference between the number of protons and neutrons will therefore have a longer half-life because they must lose more neutrons to become stable. Marie Curie discovered the first form of radiation. She found the element and named it radium. She was also the first female recipient of Nobel Prize. Frederick Soddy conducted an experiment to observe what happens as radium decays. He placed a sample in a light bulb and waited for it to decay. Suddenly, helium containing 2 protons and 2 neutrons appeared in the bulb, and from this experiment he discovered this type of radiation has a positive charge. James Chadwick discovered the neutron by observing decay products of different types of radioactive isotopes. Chadwick noticed that the atomic number of the elements was lower than the total atomic mass of the atom. He concluded that electrons could not be the cause of the extra mass because they barely have mass. Enrico Fermi used the neutrons to shoot them at uranium. He discovered that uranium decayed a lot faster than usual and produced a lot of alpha and beta particles. He also believed that uranium got changed into a new element he named hesperium. Otto Hahn and Fritz Strassmann repeated Fermi's experiment to see if the new element hesperium was actually created. They discovered 2 new things Fermi did not observe. By using a lot of neutrons, the nucleus of the atom would split, producing a lot of heat energy. Also, the fission-produced products of uranium were already discovered: thorium, palladium, radium, radon, and lead. Fermi then noticed that the fission of one uranium atom shot out more neutrons, which then split other atoms, creating chain reactions. He realized that this process is called nuclear fission and could create huge amounts of heat energy. That very discovery of Fermi's led to the development of the first nuclear bomb called Trinity.